Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, subscribe to my channel. In this lesson, we'll be looking at how to use the chain rule to differentiate trigonometric functions. So join me as we go through. Now, if we have, say, y equal to u exponent n, where u is a function of x, then the chain rule is telling us that the derivative of y with respect to x is equal to the derivative of u with respect to x times the derivative of y with respect to u. Now, let us take the first example. If you have y equal to cosine 2x. Now, how do we use the chain rule to differentiate this? So here you see that we have cosine and we have 2x. So we will let this to be equal to u. So we are going to have y equal to cosine u, and that we have dy on du equal to, if you differentiate cosine, you get negative sine u. And what is u? We are saying that u is 2x. So you have negative sine 2x. Now, we will take our u and then differentiate it. The derivative of u with respect to x is equal to 2. So let us apply the chain rule. We have the derivative of y with respect to x is equal to du dx, that is 2, times dy du, that is minus sine 2x, and that will give us negative 2 sine 2x. Now let us take the next example. The next example, we are going to consider having h of t equal to 5 sine 4 at, where a is a constant. Here it means that 4a is a constant. Now, how do you find the derivative of h with respect to t? So here we will let u to be equal to 4at. Then the derivative of u with respect to t will be 4a. This implies that my h of t is equal to 5u. Then the derivative of h with respect to u is equal to, 5 sine u rather, is equal to 5 cosine u. If we differentiate sine, you get cosine of the same angle. Sine of this angle, if you differentiate, you get cosine of the same angle. So this will give me 5 times cosine u, and u is 4at. So now the derivative of h with respect to t will be du dt, that is 4a times dh du, 5 cosine 4at, and that will give me 20a cosine 4at. Very simple as that. So now let's check the next example. So the next example, we are moving higher. We are going to take y is equal to cosine to the power 7, and the angle is 5x squared minus 6. So now this one can be rewritten as y equal to cosine 5x squared minus 6 all to the power 7. Wow. So we are going to use the u substitution here. So we are going to take u equal to the inner function cosine 5x squared minus 6, then it means that y is equal to u to the power 7. Now, I can take this one, that is the derivative of y with respect to u will be 7u to the power 6. And that is the same as 7 times u. U is the inner function. So, okay, let me bring it here. Derivative of y with respect to u is 7u to the power 6. That will give me 7 cosine to the power 6 5x squared minus 6. Note that if we bring the 6 here, it is wrong because there's a difference between cosine, let's say 30 squared, is not equal to cosine squared 30. This one means cosine of 900, and this one means cosine of 30 all squared. That is, after you punched cosine of 30, you square the result. This one, square 30 and then punch cosine of the results. So you have to note it very carefully. So that is why I brought this 6 here, meaning that I should have put this in bigger bracket and bring the 6 here, but it is the same as bringing the 6 here. That is why I've done it like that. Okay, so that is the derivative of y with respect to u. Now, if we take u, it is equal to cosine of 5x squared minus 6. Now, we are going to differentiate this, and this one too will need the chain rule again. So this one, we will let a equal to 5x squared minus 6. And now the derivative of a with respect to x will be 10x. This implies that u is equal to cosine a. Now the 5x squared minus 6 is a. So here too, the derivative of u with respect to a is equal to, if you differentiate cosine, I have negative sine a. And what is a? 5x squared minus 6. So minus sine 5x squared minus 6. Now you are good to go. So here, the derivative of u with respect to x will be dA dx, that is 10x, times du dA, that is negative sine 5x squared minus 6, and that will give us negative 10x sine 5x squared minus 6. Okay, so now I've got du dx, and this is our dy du. So we are going to combine du dx and then dy du to get our dy dx. Okay, so let me clean this part. Let me clean this part. So now dy on dx will be du dx is this. dy du is this rather. So dy du is 7 cosine to the power 6 5x squared minus 6 times minus 10 sine 5x squared minus 6. So this will give us minus 70. X is there. Yes. Minus 70x cosine to the power 6 5x squared minus 6 sine 5x squared minus 6. That is the derivative of y with respect to x. Very simple as that. So now let's take the next example. I've been telling you that these examples are not the exact questions you may get in your exams, but how we are evaluating them will help you very, very much. So let's take this one. The next question is we have y equal to sine to the power n times ax squared plus bx plus c. How do we differentiate this? This is the same as sine ax squared plus bx plus c all to the power n, and then we take u to be equal to the inner function sine ax squared plus bx plus c. We take the derivative of u. No, we can't take it. This is also chain rule. So the inner function must be represented by another term. So let me take h equal to the inner function ax squared plus bx plus c. Let me use t rather. Here, this will imply that u is equal to sine t. Here, the derivative of t with respect to x is 2ax plus b. And the derivative of u with respect to t will be cosine t. So here, the derivative of u with respect to x will be dt dx times du dt. And that will be 2ax plus b. You have to put it in brackets and bring cosine t. If you forget about brackets, you are wrong, because it is not only the b that is multiplying the cosine t. And here, what is t? T is ax squared plus bx plus c. So we put it there, ax squared plus bx plus c. Now, we've done with differentiating u with respect to x. It has left with differentiating y with respect to u. So we have y equal to, we said the inner function is u. So here we are going to have u to the power n. That is, this inner function is u. So here the derivative of y with respect to u is n u to the power n minus 1. And this is the same as n. U is what? All these. So we have sine into bracket a x squared plus bx plus c. Then we bring our n minus 1 to the top here. Or we can put this in brackets and then bring the n minus 1 here, as I've explained earlier. So let's put the n minus 1 here. Correct. So this is the derivative of y with respect to u. So now we can take derivative of y with respect to x. We have du dx, dy du. So we multiply this by that. That is the chain rule. So the derivative of y with respect to x will be 2ax plus b cosine ax squared plus bx plus c times n sine exponent n minus 1 ax squared plus bx plus c. And that will give us 2ax plus b sine to the power n minus 1 times, into bracket ax squared plus bx plus c, and then we bring cosine. Now n is here, so let's bring n in front. Correct, n is here. So cosine ax squared plus bx plus c as our final answer. Very simple as that. I hope you are enjoying the lesson. Please leave a comment, share, and then also like the videos. Now let's take the next example. In the next example, we are going to consider cosec. We are going to consider cosec. We are going to consider cosec, cosecant. So let's consider the next example. We have cosecant ax squared. Y is equal to cosecant ax squared, where a is a constant. So how do we differentiate this? Here we will let this one to be u. So we have u equal to ax squared. That is the chain rule. So the derivative of u with respect to x is 2ax. And now we have y to be equal to cosecant u. And if you differentiate cosecant u, you get negative cosecant cotangent. So this will give us negative cosecant u cotangent u as dy on du. And what is u? Ax squared. You have minus cosecant ax squared cotangent ax squared. Now we have our dy, du, and du dx. So now we can multiply them to have dy on dx. So we multiply this 2ax times negative cosecant ax squared cotangent ax squared. This will give us 2ax, negative is here, cosecant ax squared cotangent ax squared. Wow, very simple as that. Now let's take the next example. Let's take the next example. So I've done this one. Go. I've done this one. I've done this. And I have done this. And I have done this. Okay, let's move on to the next example. Now the next example is we have y is equal to cotangent to the power 8 5x squared minus 6. So how do we do this one? We have y to be equal to cotangent 5x squared minus 6 to the power 8. And we take u to be equal to the inner one, cotangent 5x squared minus 6. This one also involves the chain rule. Remember that here it will imply that y equal to u to the power 8. Wow. So this one will also take the chain rule. So here let us make a to be equal to 5x squared minus 6. This implies that u equal to cotangent u, cotangent a rather. So here the derivative of a with respect to x is 10x. That is 2 times 5, we get 10. And here the derivative of u with respect to a is negative cosec a, as we have negative cosec squared as we have here. So this will give us negative cosec squared a. A is 5x squared minus 6. So we put here 5x squared minus 6. Now you can find du dx. Du on dx is dA dx times du dA. And that is minus cosec squared 5x squared minus 6. And that will give us minus 10x cosec squared 5x squared minus 6. That is the derivative of u with respect to x. So now you can find dy du and then multiply them together to get dy dx. So here, dy on du is 8u to the power 7. And that is 8. And what is u? U is the inner function. That is cotangent 5x squared minus 6. So I write here cotangent 5x squared minus 6 as the derivative of y with respect to u. So you are going to multiply them together. The derivative of y with respect to x is equal to du ds minus 10x cosecant squared 5x squared minus 6 times 8 cotangent to the power 7 5x squared minus 6. Please don't be confused. We want dy dx, so we will let all these to be our u. Once you've made this as u, this one will also involve the chain rule. So what is in here will be a. Then you apply the chain rule to this expression to get du on dx, and that is what we've done here. So you find dA dx, du dA, dA ds, du dA. So we multiply them together to get du dx, and that is what we had here. After that, we differentiate y with respect to u, and we had this. Very simple as that. And then we are going to multiply them together. So this will give us negative 80x cosecant squared 5x squared minus 6 cotangent to the power 7 5x squared minus 6. Wow. As minus 80x cosecant squared 5x squared minus 6 cotangent to the power 7 5x squared minus 6. Very, very simple. Now let's take the next example. I hope you are enjoying the lesson. Yes. This is very simple ones. So let me cancel what I've done so that I will not repeat it again. The next one, we are going to take f of x is equal to tangent to the power 5 3x squared minus 2x plus 1. Now, we write f of x to be equal to tangent 3x squared minus 2x plus 1 all to the power 5. And now we will let u to be equal to the inner one, that is tangent 3x squared minus 2x plus 1. And this will also involve the chain rule. So here, this implies that our f of x is equal to u to the power 5. And I can find the derivative of f with respect to u as 5u to the power 4. And that will give us 5 tangent to the power 4 3x squared minus 2x plus 1 as the derivative of f with respect to u. So we are now going to find the derivative of u with respect to x and then come and multiply them together. But this one also involves the chain rule. So I will let say a to be equal to 3x squared minus 2x plus 1. Now the derivative of a with respect to x is 6x minus 2. Now we have u to be equal to tangent of a, because all this is being represented by a. So we have the derivative of u with respect to a. If we differentiate tangent, we get secant squared. So we have secant squared a, which is the same as secant squared. A is 3x squared minus 2x plus 1. So you put 3x squared minus 2x plus 1 there. And that is our du dA. Wow. So now we have our du, dA, we have our dA on dx. So now we take du on dx to be equal to dA on dx times du on dA. And this means we have 6x minus 2, you put it in brackets, and this one is secant squared, 3x squared minus 2x plus 1. That is the derivative of u with respect to x. So now we are going to multiply it by the derivative of f with respect to u to get the derivative of f. Wow. So now, let me clean this portion. So now we have our f prime of x to be equal to, we take this one, 6x minus 2 secant squared, 3x squared minus 2x plus 1 times 5. 5 tangent to the power 4, 3x squared minus 2x plus 1. Wow. So now this 5 will come, you can multiply it through this or you can leave it there. But let's multiply it through. We're going to have 30x minus 10, put it in brackets, secant squared, 3x squared minus 2x plus 1, then tangent to the power 4, 3x squared minus 2x plus 1 as f prime of x, sorry, the derivative of f with respect to x. Now, let's take the next example. So we are done with the tangent. Let me cancel it out. We've left with 1, 2, 3. Just 3 examples for us to go. So that is how we differentiate using the chain rule. Now this one, we have y equal to secant into bracket ax squared plus 5bx minus 10. This is straightforward. Here we let u to be equal to ax squared plus 5bx minus 10. Now this implies that y is equal to secant u. So we take du on ds to be equal to 2ax plus 5b. These two multiply a to come to ax. Here we take the coefficient, that is 5b. Derivative of 10 is 0 since 10 is a constant. Now we take derivative of y respect to u. If we differentiate secant, you get secant u tangent u, and this will give us secant u is what? Ax squared plus 5bx minus 10, and then this one will be tangent ax squared plus 5bx minus 10. Wow. So now the derivative of y with respect to x is du ds times dy du. So here we have 2ax plus 5b. You have to put it in brackets. Times all these, secant ax squared plus 5bx minus 10 times tangent ax squared plus 5bx minus 10. And we are done. Wow. Now let's go to the last but one example. Now that example is cosecant to the power 5. we have y equal to cosecant to the power 5, 7x squared minus 5x plus 2. So we have y to equal to cosecant 7x squared minus 5x plus 2 all to the power 5. And here we let u to be equal to cosecant 7x squared minus 5x plus 2. This implies that y is equal to u to the power 5. So, how do we find dy on dx? We have to find du on dx times dy on du. So here you can find dy on du as dy on du equal to 5u to the power 4, and that will give us 5. And what is u? U is cosecant to the power 4, 7x squared minus 5x plus 2. So we found dy du, that left with du dx. So if we consider u is equal to cosecant 7x squared minus 5x plus 2. This is also chain rule. So we let a to be equal to 7x squared minus 5x plus 2. And the derivative of a with respect to x is 14x minus 5. Now, this implies that u is equal to cosecant a, and the derivative of u with respect to a, if we differentiate cosecant a, you get negative cosecant a cotangent a, as we have here. So this will give us negative cosecant a. A is 7x squared minus 5x plus 2. So we write 7x squared minus 5x plus 2, and cotangent 7x squared minus 5x plus 2. Wow. So now this is du dA and this is dA dx. So we multiply this by that to get our du dx. So du on ds is equal to dA on dx times du on dA, and that is 14x minus 5. We put them in brackets, then you multiply it by that. Here there's a negative sign here, so let me bring the negative sign in front first, and then I'll add all these. Cosine into brackets, sorry, cosecant into brackets, 7x squared minus 5x plus 2, and then cotangent into brackets, 7x squared minus 5x plus 2. Wow! What a long expression. Now, this is our du dx. This is our dy du. So, this is dy du dx. We are going to multiply them together. So, the derivative of y with respect to x will now be du dx, and this is what we have, minus, we can send the negative sign inside, but if we send the negative sign inside, the bracket still remains, remember. Okay, so we have cosec 7x squared minus 5x plus 2. We have another cosec. Okay, let's write all these first. Then cotangent 7x squared minus 5x plus 2 times 5 cosecant to the power 4 7x squared minus 5x plus 2. Now we have 5 here, so we are going to multiply through this by 5 minus 70x plus 20. That is 5 times 14 is 70. So here, what do we do? We have cosecant 7x squared minus 5x plus 2, and here is cosecant to the power 4. So cosecant to the power 4 times this will give us cosecant to the power 5, 7x squared minus 5x plus 2. You have to note this very well. This is cosecant to the power 4, this is cosecant to the power 1, and the angles are the same. So we add the powers. And we have here as cotangent 7x squared minus 5x plus 2 as our final answer. Very simple as that. So we are done. And let's take the last example. The last example, and we will move again. The last example. This is our last example. The last example is g of t is equal to secant no, it's sine rather. Sine to the power 3, 5x, I've been using 5x. Let me write 3x minus 6. Very simple as that. So we have t. Once you have g of t. So here g of t will be sine 3t minus 6 all to the power 3. And now we take u to equal to sine 3t minus 6, and that g of t equals u to the power 3. So the derivative of g with respect to u will be 3u squared, and that will give us 3 times sine squared 3t minus 6. Now, if we take u to equal to sine 3t minus 6, what are we going to get? We are going to get a equal to 3t minus 6, because this is a chain rule. Now, once this is a chain rule, yes, I forgot to do secant, a power to a secant. So this one will not be the last example. We will take a power to a secant and see what we will get. Okay. So here the derivative of a respect to t will be 3. Very simple. Will be 3. So now what are we going to do? We have u to be equal to sine a, and the derivative of u respect to a is cosine a. Wow. And a is 3t minus 6. So the derivative of u respect to a will be cosine 3t minus 6. Perfect. So now we have dA on the t and du on the a. So you can find du on the t. So this implies that du on the t is equal to dA on the t, that is 3 times du on the a, 3 times cosine 3t minus 6. Very simple as that. Now, we can multiply these together to go ahead. So, we can now find g prime of t. So here g prime of t is now dg on du dot du on dt, and that is 3 sine squared 3t minus 6 times 3 cosine 3t minus 6. And what are we going to get? 9 sine squared 3t minus 6 cosine 3t minus 6 as our final answer. Very, very simple. So let's take the secant to a certain power and then we say goodbye. So let's take secant y equal to secant to the power 4 x squared minus 2. Simple one as this. Here we have y equal to secant x squared minus 2 to the power 4. Yes. And now if we let u to be equal to secant x squared minus 2, it implies that y is equal to u to the power 4. Here, this one requires chain rule. So let's do the derivative of y with respect to u is 4u to the power 3. And that will give us 4 secant to the power 3 x squared minus 2. So let's put 1 there. Here, if we let a to be equal to x squared minus 2, dA on dx is 2x. And now this implies that u is equal to secant a and du on dA is, if we differentiate secant, you get secant a tangent a. So that will give us secant x squared minus 2 tangent x squared minus 2. Wow. So we multiply dA dx by du dA to get our dA dx. To get our du dx. So here, du on dx is equal to dA on dx dot du on dA. And that will give me 2x times secant x squared minus 2 tangent x squared minus 2. Now I have divided du here and I have du dx. So I can multiply them together. So the derivative of y with respect to s will be du dx dot dy on du. And that is du dx is 2x secant x squared minus 2 tangent x squared minus 2 times 4 secant cube x squared minus 2. Wow. Secant cube times secant to the power 1. The angles here are the same. So we just add the powers. This will give us 2x secant to the power 4 x squared minus 2 tangent x squared minus 2 as our final answer. Thank you for watching and please subscribe to my channel. Bye bye.